Hello?
We can hear you, Shirley.
Okay, okay. So I guess it's good. Thank you so much. Good morning. Well, hello. I hope you've been having a really great day. Thank you so much for letting me finish off the first day of your conference. And I want to also thank Christian and Sarah and Brian, everybody on the organizing team that I haven't quite gotten to meet or talk to. I want to thank you so much for organizing this and doing this. And I feel like it's something really amazing and something I feel like significant that you've let me be a part of. So I want to thank you so much for that. And I want to talk to you today about data visualization for web developers. Hi, my name is Shirley, and I'm an independent creator of data visualizations. I started out studying business and computer science in college, and when I graduated, I went to a big data company doing front-end development, right when they were trying to move from high charts to D3. And being that new kid in the office, they asked me if I was interested in learning some D3 and doing some projects with it. And I loved it so much that I decided that I wanted to do it on the side for fun. And so I started doing all of these side projects in data visualization. And I loved that so much that I decided to quit my full-time job and go full-time freelance doing data visualization projects. And I've had the most amazing opportunities to work with different companies across different industries, helping them explore their data, figuring out insights to build visualizations around, and building data stories. And perhaps because of that, sometimes I get asked the question, how can I get started with data visualizations for the web? And the answer I usually give is, give yourself a project and practice lots, like lots. But that's a really oversimplified answer for quite a complicated question. So I wanted to take this opportunity to talk through some of the projects I've done in the past and the lessons I learned from them. So let's start. The very first lesson is about data, and it's that when you're trying to start a data visualization project, find a topic that you're really curious about, and then go out and find the data to satisfy that curiosity. Because that curiosity and excitement will push you through that project and help you finish it, motivate you to finish it, especially when the project gets hard. 2 years ago, I was really obsessed with this one musical called Hamilton, and I was so obsessed with it that I had it on repeat, and I started kind of analyzing the lyrics for themes and recurring phrases, and it got to a point where I was just like, okay, I should just visualize this. And so this is it. An interactive visualization of every line in Hamilton, where every single one of these dots is a set of lyrics sung by a character in the musical, and I give the reader the insights I found with the analysis that I did until they get to the very end, where I give them the full exploratory tool I used to find those insights, where they can, for themselves, filter by any set of characters, conversations, and themes, and dig into the remaining lines to do their own analysis. When I started on this project and I was trying to go out and get the data, the questions I had were, how do the relationships change between the characters throughout the musical? And what recurring phrases are associated with whom? And as you can probably imagine, none of this data was readily available out there online. And so I had to go manually create the data myself. And so first, I went through the lyrics. I went through the lyrics twice, actually. But the first time around, I went through the lyrics and noted any recurring phrases. And then I grouped those phrases into themes. And I went through the lyrics again, this time manually entering all of the themes and all of the characters and conversations that happened throughout the musical. And I wrote a script to aggregate those songs by line number until I got my final data set. And this project really taught me, this project and many similar ones really taught me that as long as I have a curiosity, I can get any data, I can go out and get any data I want within reason and within the law. As long as I'm willing to do some manual data entry or write some automated scripts. So once we have the data, we have to make sure to explore that data before we get started on the designing. This is a side project of mine called 4 Years of Vacations in 20,000 Colors, where I take all of the colors from all of my past trips, I group them into the trip that they were taken on, I arranged them by the day of the trip that they were taken on, and this is one of my favorite projects because I feel like I've learned a lot about myself when I was doing this, which is that at first I was really, really confused because I knew that when I go on vacation, I really love nature and I love taking pictures of nature. So all of these blues and greens made sense to me because they must be like pictures of waters and lakes. But what I was really confused about was all of these reds and oranges that I was seeing because I knew I wasn't waking up for any sunrises. And when I dug into the underlying photos, it turns out that these oranges and reds were food pictures. So I really learned a lot about myself through this visualization about how I travel, which is apparently that, for example, this trip to Asia and to Japan, apparently all I did was eat. But this one was to Iceland and there was a lot of waterfalls. And so there was a lot of green. And I really like this visualization for how much it taught me about myself. But it didn't actually start out so well. It actually started out really, really disastrously, which was that when I got all of the data, and when I had finished getting all of the data and I was ready to start designing, I was so exhausted by just getting the data that I actually didn't explore the data before I started the sketching. And when I started the sketching and trying to design, I feel like I had really great intentions, which is that I was really curious about where and when I took my pictures. And so I wanted to do that where the y-axis was time, so when I took those pictures, and the x-axis was time of day or where around the world. But you can see that there's no hint of me ever actually exploring the actual data set, and there's only a note in here about how to technically implement it. And because of this, this is what happened. This is what happened when I actually plug the data into the visualization. I like to lovingly, when I plug the data into the design, and I like to lovingly call this man peeing into puddle. And I like to consider this my postmodern contribution, art contribution, but I also knew that this wasn't a good final visualization. So I had to take a step back and go in and look at the data and really ask myself, what metadata does each of the photos have? Does each of the data points have? And when I did that, I realized that the data I had, I knew which trip it was taken on. So I could group each of the colors by that trip. knew what day it was taken on, so I can actually sort it along by angle, and I can sort it based on the day of the trip. And I also had hue, saturation, lightness information for each of the colors. And so I can sort it along the radius like that also. And that's how I got to my final visualization. And this project really taught me to list out all of my data attributes so that I can assign them to visual channels. Visual channels being things like XY positions, sizes, color, shapes, and make sure to watch out for the extremes also. Now, once we've done the exploration, the data exploration, and we've gotten a basic understanding of the data, the next step is to design a visualization to showcase that data, which to me is one of the hardest things to do as a developer. So over the years, I've created a set of guidelines for myself to help me with the design process. And one of the most important rule in there is to design with a question in mind. And if that question leads nowhere interesting, try a different question. Last year, I had the opportunity to work with Google News Labs and their search data dating back to 2004. And I decided to look into travel data and in particular, what people around the world search for in terms of travel in different seasons, across different countries, and the topics in those countries and the search interests and thus the seasonality of each of those topics. When I started on this project, I knew that I wanted to do something with travel, but even with that constraint, it was still a huge, massive data set. And so I decided to narrow down with some questions. And the very first question that I asked was this: what is the top search country for travel? And who's searching for that country? And this was a little bit interesting, but not interesting. I didn't find that particularly interesting, other than perhaps the fact that countries nearest to the country in question searched most for that, the countries nearest, the neighboring countries searched the most for that particular country. But other than that, I didn't find this question and the answers that it gave me particularly interesting. So I decided to change to a different question, which is what kind of topics are being searched for in each country? And this design was really confusing and hard to read, so I tried a different design to answer this question and another. But perhaps it was these designs, perhaps there really was nothing interesting about this particular question, but I didn't find any of them compelling. So I decided to take a step back and concentrate on something else that I had noticed earlier, which is, does geography play a part in who searches for a country? And I tried several iterations of designs to answer this question too, but I was dissatisfied with all of them. And I was getting really desperate and I wanted to find something interesting. And that was when I remembered that I had noticed something really interesting about seasonality in my earlier data exploration. I was wondering if I could do something about it. And initially, it didn't look that interesting until I tweaked my design just a little bit. And there it was, insights. In particular, that at least for people in the US, we search for travel and vacation much more in the spring and in the summer than we do in the fall and the winter. Now, I'm not saying that you have to go through all of this back and forth that I did for this project, especially because it's super time consuming. But I would encourage you to get the data onto the screen as early as possible with software like R or Tableau, or even with D3 and other charting libraries. And that's because, unlike a normal design process, I find that there's no clear handoff between design and code when we're building visualizations. Very rarely can we predict and design exactly what the data will look like on the screen. So make sure to get the data onto the screen as early as possible in your design process. We've talked a lot thus far about how to get the data, how to explore the data, how to design for that data. And now I want to talk about code, which I think is what we're all really, really good at. And I want to talk about how to code visualizations in the web. And you might imagine that that's a little bit different from how we might create a website, in that visualizations is all about drawing shapes onto the screen with SVG or Canvas. And the best thing I ever did for myself is to teach myself SVG paths and get a little bit better with math and trigonometry, because with those under my belt, I find that I can draw any shape that I imagine up in the browser. So this is another one of my side projects called Film Flowers, where I reimagined top blockbusters, summer blockbusters in the last 2.5 decades as flowers, where each of the petals are parental guidance ratings, each of the colors are different genres, and the size and number of petals is their IMDb rating out of 10. And there's some really beautiful ones in here, like The Dark Knight Rises and Inception. I always love Harry Potter, but my absolute favorite that I share every single time is this 1997 Batman and Robin, because of how tiny and cute it is. But when I first published this project, I sometimes got the question of, oh, how long did it take you to do this? Or how hard was it? And the answer is, it actually really wasn't hard at all to draw these. It actually was quite straightforward to draw all of these flowers. And all it takes is an understanding of SVG paths and the cubic Bezier curve command. I want to show you how I drew this cherry blossom. And I'm going to start with just the petal. And the way that I draw the first curve is, I think of it as starting from a point, the 0, 0, and I draw a straight line and down to the endpoint, the purple endpoint. I then take the blue and green anchor points and I drag them out and I move them out until I get the curve I want. I draw 2 straight lines. I draw the curve on the other side. I rotate the flower petals, add some colors, blurred colors, and that's it. That's all it takes. That's all the code it took to make these flowers. But drawing shapes onto the screen won't give us the whole visualization. It won't help us translate the data onto the screen. And to do that, you might have heard of something like something called D3, a JavaScript library that helps draw visualizations onto the web browser. But you might also have heard that there's a little bit of a learning curve when picking up D3. And that learning curve is usually the enter, update, exit pattern, which is how D3 manages updates to the DOM. But these updates to the DOM are actually what frameworks like React and Vue are really, really great at. And so I would encourage that you use React and Vue and D3 together to draw visualizations because they actually go really well together. And to show this and how to do this, I want to share this really simple set of visualizations with you where I visualize the weather data of 3 different cities. And I want to actually live code 2 of these with you, this bar chart and also this radial chart. And so I hope you'll be patient with me as I do this, but I want to show you how you can use D3 to draw the visualization, to calculate the visualization, and for React to render them. So to start with the bar chart, our data looks like, our data is for every single one of the days, the data we have is the date, the high temperature, the low temperature, and the average temperature. And these that you see, these bar charts you see are made up of 365 SVG rectangle elements. And to draw rectangle elements on the screen, you need the X position, the Y position, the width, and the height. And so what I want to do is map the date to the X position, the high temperature to the Y position. I want to calculate the height as the difference between the high temperature and the low. And finally, I want to fill the color with the average temperature. And to do this, D3 gives us a really great set of utility functions called D3 scale. So for the x-axis, I want to use D3 scale time, and I want it to translate between the min and max dates to 0 and the width of my visualization. And to do that, I give it the domain, which I calculate as the minimum and maximum dates, and I map that to 0 and width. And then I calculate my Y scale. And I want that to go from the minimum and maximum of the high temperature. Oh, actually, I want it to go from 0 degrees to the maximum high temperature. And I want that to get mapped to height and 0. And finally, I want my colors, and I want to just use a built-in D3 color scale. And so that is interpolate red, yellow, blue. And I want to map that to the min and max of the average temperature. D.average. And so the minimum average temperature will get mapped to the blue, and then the maximum will get mapped to the red colors. And now that we have all of the D3 scales, we can just create an array of objects where each object represents one of the bars. Let's do that. So data.map D. And I'm going to return an object that has the X, which is the X scale, pass in the data, or pass in the date for that particular data point. Y is the Y scale, and pass in the high temperature. Height is equal to the difference between the low temperature on the Y scale and the high temperature on the Y scale. And And the fill is pass in the average temperature to the color scale. Let's console log these bars to see that we did it correctly. And pass the bars back as state. Oh no. Okay, so we can't do the color today because it turns out I have the wrong version of D3. So it's just going to be all black bars today, and I apologize. But let's make sure that we have the bars calculated correctly. And here we are, we have 365 objects with the X position, Y position, and the height. And now we can use that in the React render function, and we can just say state.bars.map, and we want to return a rectangle element for each one of them, where we use d.x, d.y, and then the width, let's just give it a random 2, and the height is d.height. And we should see a bunch of, nope, this .state.bars. Oh, I'm sorry. I forgot to do this part, but now we should be able to see a bunch of black bars that show up. And I apologize for, thank you, wow, thank you so much. I actually haven't been able to see the audience during this whole time, and I'm getting like a little bit sadder and sadder, but I'm so glad to hear that. Thank you so much for that really loud whoop. And that makes me really happy. Okay, thank you. Oh, I'm so happy right now. So that's how easy it was to get these bars. And then let me show you how easy it is to get these axes on there. So now we have to do a little bit of, we have to shift the bars over by a little bit to make room for these axes. So what I'm going to do right now is, instead of mapping to 0 and width, I map to margin.left to give a little bit of room. I subtract margin.right. And I subtract margin.bottom and margin.top. And then you'll see that this should give a little bit room on the left and the bottom. And then I'm going to create a y-axis using d3.axis left. No, so y-axis is on my left. So d3 axis left. And then I'm going to create an x-axis, d3 axis bottom. And then in component did update. And in render, actually, let me do render first. I need to give a group element and a group element, and then let me give it a ref of x-axis and another group element, a y-axis. And then in component did update, if I did this correctly, I can just say select the x-axis group element with D3 and call the y-axis, the x-axis that we created earlier, passing in the scales and if I did this correctly, there should be const. Oh, sorry, I shouldn't have const. If I did this correctly, there should be some numbers that show up at the top. Oh no. Oh. I'm really sorry about that. So let me actually move on and show you the radio chart, because So I think I'm running out of time a little bit. So please be patient with me. Let me show you how to do the radio chart. Oh. And I want to show you how easy it is to do this also. And so to do a radio chart, what we need is the radius. So I want the date to be mapped to the angle, and I want the temperatures to be mapped to the radius. And then D3 has this thing called an arc generator, where if I pass in the start angle, end angle, and inner radius, outer radius, it will give me back what I need to draw each one of these slices. And so let me go and create the scales. So the radius scale is equal to d3.scaleLinear, and get the domain, which is I want to map it between 0 and 0 degrees, and d3.max data and the high temperature, and map that to and map that to 0 through width divided by 2, and I want to do per slice angle is equal to 2 times math.high divided by data.length. And I'm going to try and do this as quickly as I can. And I'm going to, for each of the slices, what I'm going to do is data.map d, and for each one of them, I want to return a start angle, which is I times per slice angle, and I want to give it an end angle, which is I plus 1 times per slice angle, and then inner radius is the radius scale of the low temperature, and outer radius is the radius scale of the high temperature. And hopefully, if we did this correctly, I can show you the slices really, really quick. And let's see that we did this correctly. And we did. So if I just map each one of them to a path element, an SVG path element, and I give it the D attributes, where I should just be able to do this and hopefully get a bunch of black slices. And there we go, there's a bunch of black slices. Thank you so much. And then I just have to put that into the middle. So bear with me as I do this last little part.
Well done, Shirley. My head has burst.
And that's it. And that's it. That's all it took. These are all the lines that it takes to do this. And I just wanted to thank you so much for letting me show you how easy it is to do data visualizations if you do D3 and React or D3 and Vue. And today, I just want to wrap this up by saying, start out small. Start out small, start out with just using React and D3, try out some simple charts. Once you feel really comfortable with that, try creating custom shapes with SVG paths. Once you feel comfortable with that, try recreating a chart with your own designs. And find a curiosity, go out, get data, and explore it. And that's when you'll find with each of these little steps that you can create, that you've created a custom database from start to finish. And you might ask, so what? So what? I might not be creating any data visualizations for work, but you might find that if you do this on the side, that you'll start to enjoy and you'll start to think critically about data. And that might be really important in this world that we live in now with so much data. But most of all, I hope that you'll go out and give data visualizations a try. And I hope that you enjoy it and love it so much that you'll join me in creating custom data visualizations for the web. Thank you.
Thank you, Shirley. That was beautiful.
Thank you. I'm sorry for running over.
That was mind-blowing. Thank you very much.
Thank you.
Really mind-blowing.
Thank you so much.
Let's give her another round of applause.
Thank you. Thank you so much.
Any questions? Maths, trigonometry, React, D3. No questions.
You have my Twitter. Please ask me anything on there.
Shirley, there's one question. We have one question for you.
Okay.
Recommended resources and tools.
Oh, actually, so I've actually gotten that same question before, and I've tweeted it before, and I can do that again. But in terms of recommendations for how to get started with the data for data visualizations, I would recommend, looking at the D3 library, what that offers. I would recommend trying using that with React. And I would recommend, after doing that, I think the design part is the most important for data visualizations. So looking at different books about data visualization, my favorite is Alberto Cairo's The Functional Art. And then there's a lot of free resources online, websites that talk about data visualization. And so my favorites on there is Nathan Yau's Flowing Data, Andy Kirk's Visualizing Data, and follow these, get a sense for the design, follow people on Twitter, watch talks from OpenVisConf, and I think if you just kind of keep at it, I think those would be the best resources I've come across in the last few years. Thank you.
All right, thank you, Shirley.
Thank you. Yeah.
All right, bye.
Thank you so much. Bye-bye.
That was